Let's talk about application layer. So in application layer, we study about protocols, especially they are required for exchanging of the information. So there are various ways of exchanging of information is required. Sometimes you want to access some web pages, right? For that, the idea will be different than transferring the file. So that's why to access the web pages you need some systematic rules. To access the files, that means to transfer the files from one place to another place, we need some set of other rules. That's why various protocols are have been proposed, I can say. To access the web pages from one computer to another computer, otherwise from one server to some client, we use a protocol called HTTP. Similarly, to access the file, that means to transfer the file from one place to another place, so we require some protocol, that is FTP protocol. Okay, you need some rules for that. So that rules are called FTP rules, otherwise file transfer protocol. To transfer the file we require protocols. To access the web pages some different kind of rules are required, they are called HTTP protocol. And to send a mail to your friend, then you have to use some systematic rules that is different from these two. Okay, so that's why various kinds of protocols have been proposed. Okay, depends on your requirement. Do you want to access the web page? That is one application. So for that we need some different protocol, that is HTTP, right? So we are going to study various protocols, depends on your requirement. Accessing the web pages, for that we require protocols HTTP. For file transfer we use file transfer protocol, and for accessing the mail or to send or retrieve the mail we require a protocol, that is SMTP. And similarly, you want to know the IP address of your computer, then you need a protocol called DNS, domain name system. We will see one by one. So before going to that, first of all I would like to tell you, so your network applications will have architecture. There are two types of architectures are possible, so it's very easy to understand. Example, let's say there are two computers, okay, and one computer wants to take the data from another computer, that's it. Okay, so one computer is called client here, another computer from which we want to access the data is called server. So when always you take data from one computer, that means one computer wants to access the data from another computer, that means accessing of the data is one directional. Most of the time you will be busy taking the data from the other computer, then we say that there is a client and there is a server. This kind of structure is called client server model. That is one architecture possible in the world. Second architecture, you can connect your computer such a way that there is no distinction between them, that means there is no priority of among them. Example, there are four computers, they want to compute something distributively. Okay, for that it is not a client server architecture, this is called P2P architecture. That means in that every computer or every peer is going to be equal. But in client server architecture, so client is different and server is different. There are roles, right? Here there is no role. Every computer is same. Everyone will have same priority, and they do all that computers are going to do the same work. Such kind of architectures are called P2P architecture. Currently in the in the world we have two kinds of architectures. One is client server architecture. Second one P2P architecture. We use both of them. Example, Skype is one example which uses P2P architecture. Okay, and example, let's say you are accessing some website. For that you will become a client, that website owner, otherwise the web server will become a server, obviously, right? So that is a client server architecture. There are two kinds of architectures possible. We can implement any of them, depends on your requirement. Now, so studying application layer is nothing but understanding the details about various things in application layer. So you understand now network application architecture. Now we see interface between process and network. When you are in application layer, that means you can divide your entire layers into two parts. This is your process in application layer. Already we have studied applications, sorry, process, everything in TCP, right? So this is your TCP and all underlying layers. Okay, TCP, network layer, everything. Forget about other layers because we don't directly involve with them, correct, isn't it? So we directly connect with application layer is going to use services of TCP. Okay, so maybe this is transport layer, maybe UDP also, anything. Okay, it depends. Do you want TCP or UDP? It's up to you. Finally, what I want to say is your applications are going to communicate with transport layer through an interface called socket. Here in this picture I am showing, you have a process in application layer. There is another system in that also there is a process. These two processes can communicate using underlying transport layer. For that we need an interface. How this process is going to communicate with the underlying transport layer protocol, whether TCP or UDP, is using socket. So this socket is nothing but like a doorway, like a door between two rooms. So this process is going to put some of the details here, and TCP is using the details, and using that it is going to establish a connection. What TCP requires, think about it, other or UDP. So TCP or UDP requires what we will see with conversation. Example, let's say process is P1, transport layer protocol is, let's say, T1. How P1 and T1 will communicate through socket, we'll see. Through socket, P1 is going to give details about port number. I'll show socket clearly. Socket can be understood like an interface. Okay, through you can access transport layer services. So transport layer says that, Mr. Process, if you want anything from me, please tell process number. Okay, that means what is the destination process? That means destination port ID. That's why, so in that socket defines destination port number. Second one, destination IP address, isn't it? And of course source port number and source IP address. These four things if you provide, then TCP is going to establish a connection perfectly, no doubt on that, correct? What it requires: destination port number, destination IP address, source port number, source IP addresses. So process is going to give all the details through socket. So socket can be imagined as an interface that contains, that is a point where we can provide, through this point we can provide destination port number, IP, source port, source IP to TCP. Similarly, here there is a socket. Through this point, this other side of TCP or UDP is going to give details to this process. Understand? So this is about communication between two systems. Of course we know that already. Now we quickly move to services provided by lower layers. We know that already, we have studied enough about that services, right? So your underlying services like TCP provides what? Think about it, transport layer. Let's not particularly say about TCP, because we have TCP, UDP and SCTP also. That is generally, imagine like this, it's a secured protocol. Okay, if you want secured connection, you can go for secured connection, SCTP. Okay, now we have TCP, UDP, SCTP. Now forget about individual things. What are the services your transport layer can provide is reliable connection, example TCP, secured connection like SCTP, and high throughput. If you want throughput, go for UDP, because no connection establishment, so quickly your data will be forwarded, so your throughput will be generally guaranteed. So application layer can have this kind of services. So who is going to provide them? Transport layer. Okay, now the next point at application layer, what you should understand is what application layer protocol defines. What it defines, what is your application layer protocol is going to do. Your application layer protocol is going to define all the things about your message. It won't talk about network, it won't talk about parameters related to transportation, like how to send the data, where to send the data, like that details, congestion, errors, everything. Mostly application layer is going to talk about this message, like application layer is going to create a message and it is going to talk about structure of the message. Okay, we'll see various points clearly. First of all, the type of messages exchanged, right? Example, is it a request message, otherwise response message? Let's focus on client server architecture. If it is client server architecture, you can understand what is the meaning of this one. So the type of message, example, let's say you are a client, you will send what? Request. Example, you want some web page, then you request that web page to server, correct? So that means what? So your protocol is going to define what is the message type. That means we are going to exchange messages, client and server, but client is exchanging what kind of message? What client is going to do? It is going to send a request, correct? So by your messages are going to be defined, otherwise your application layer protocol is going to define what kind of message it is, request message or response message. Okay, so for that there should be rules, otherwise there will be a confusion. Raju and Rani are exchanging the information, and Rani wants to ask Raju like this: Raju, do you have pen? Okay, but Raju doesn't understand that. Then what is the purpose of sending that message? So that's why application layer protocols are going to define what kind of message types. That means, Rani says that, my dear Raju, this is request, in that way. So that's why when you write a message, we have to, also we also have to define what kind of message it is, request message or response, in that way. Second one, when you have a message, how to understand that, like how to divide that into parts. Generally in English communication, that is easy for us, but when it is a communication between two software entities, how one software will understand message, that is important, right? Example, if you send some data message, how receiver will understand? Receiver can understand it in so many ways. He can divide it into three parts. He can understand X in one way, Y in another way, Z in another way. But what exactly source wants? That's why there should be a common agreement, right? So that's why that is going to be provided by protocol. Protocol says like this: my dear sender and receiver, remember from now onwards, this message will have a structure. Okay, so the rule of the message is like this: there will be a syntax of various messages types, that and how they are delineated. That means, so every message will have, I can say, some set of syntax, maybe like this, four parts. I can send a message to another person, okay, and this is, let's say, what is the type of the message, maybe, okay, type of the message, some extra information, this is some integer, this is some character, and this is something, some extra thing, whatever. So if you don't divide it into properly like this, then you can't understand the meaning of the information. So that's why. And one more thing, see, hi, do you have pen, right? When you send this kind of message, then if there is no protocol in between them, how that other person can understand the meaning of this one? Definitely there should be a protocol between these two people that says that hi is one word, do is one word, you is one word, have is one word, pen is one word, right? If there is a question mark, how to interpret it? Everything, correct? So for that, these people should have a protocol, right? And especially that should be a common protocol. Example, let's say this sender is expecting, sender is expecting receiver to divide like this only, but receiver divides it into two parts exactly. Hi, do you one thing, have pen one thing. He might not understand it clearly, correct? So that's why sender receiver should have same agreement. Similarly, so that is what, who will decide that protocol? We have a protocol, right? In English language, whenever we write a space, that is the end of the word usually, correct? In the same way here also, application layer protocol is going to define syntax of the message, right? So that is especially about how to alienate the fields. When you have a message, it will have multiple fields. We have to split like this. This is some meaningful information in that way. So that is about syntax. Now about semantics. Semantics, right, whenever we write a message, so the semantics talk about how to understand what is the meaning of that. That means when you send a message, how to interpret it. So that is about semantics. How to understand it. So that is about semantics of the message. Okay. So protocol is going to define semantics and syntax and also timing. We will see what is timing. So example, let's say you get a message. Then what kind of reply I have to give and when to give. So that is about, timing. So timing about messages is nothing but when we have to respond and when we have to send some message. So that is all about timing of message. So protocol is going to define timing of messages and how to write the message, what is the syntax, and also it defines how to understand the message, and also it will tell what is the type of the messages generally possible, request message or is your message response message. So these are all theory. Okay, so generally your application layer protocol should define all these things and it will do that, no problem. Now we'll see various application layer protocols and we try to understand what are the functionalities they are going to give us. one by one. In GATE exam we have to study about HTTP protocol, second one SMTP protocol, third one FTP, after that DNS. We'll see one by one. Okay, let us see HTTP protocol. Here I would like to tell you one thing. I'm going to teach you only very essential things which are required for GATE. So this learning application layer is very big thing. That means you can learn at any extent, but for GATE generally you don't require anything other than just some information, like what is HTTP protocol, what is the protocol, what it does, third one what is the port number, and what are the message formats. That means generally what are the various types of messages possible in that protocol. That's it. Okay, if you learn that, that would be more than sufficient. That's why let me quickly complete HTTP, FTP and SMTP. Let's begin with HTTP. So why we use HTTP is to exchange the web information. That means there is a server, HTTP server, there is a client, we say HTTP client. First of all, assume that let's say there is a client, there is a server. This server is having some HTML pages or some web pages. Broadly let me tell that there are web pages. Web pages, everything, right? So now you want to access that web pages from this computer where client resides. So this is nothing but client server architecture. So now here we have a client, here we have a server. Usually in your computer, HTTP client is nothing but your web browser. Okay, now your web browser is going to be client. Similarly here there will be web server, that is going to be the server part. Okay, now so this web browser and web server are going to communicate through a protocol called HTTP. Okay, now how this protocol works, we'll see. This client web, of course web browser, is going to start the initiation. That means he will request web pages. It's very simple. HTTP, the client requests a web page, server will respond with that web page, corresponding web page. For every web page there will be a URL. So client is going to provide that URL and server is going to give the data in that. That means that entire web page will be transferred. So that is what HTTP protocol does. We have instructions for accessing the web pages. We will see that. Before that, we'll see what is persistent and non-persistent models. Your HTTP connection, now we say this is HTTP connection. So we know how we get generally connection, right? So see here, sir, how we get connection here. This is your browser, this is your, let's say server, let's say client and server. This is client, this is server. So since they are following HTTP protocol, we say HTTP client and HTTP server. And there are some systematic rules they have to follow for information exchange. Especially to get the data from server, client has to follow some specific format of instructions. That is nothing but HTTP protocol. So now we have here TCP, UDP, everything, right? SCTP. Here also TCP, UDP, SCTP. Now, client is going to use generally TCP protocol for, generally, so there should be a connection establishment between them. That's why client is going to call TCP, because we know that TCP is connection oriented service, right? So first client is going to somehow find out server's IP address, server port number 80. These details will be provided to TCP protocol. Using that, happily your TCP protocol can communicate with another TCP. So now there is a TCP-TCP communication. Hence there is a client server communication. Through this communication line, your applications are going to communicate. We know that, of course, TCP is going to provide that line. Now we talk about this client and server, what they are going to do. Simple. Client is going to request a web page, server give it. That's it. Okay. Now, sir, what is this persistent, non-persistent? I will tell you. Once whenever client wants some web page, let's say web page number 1, server is having lot of web pages, web page 1, web page 3, web page 3. So client will request web page number 1. My dear server, I want web page number 1. I know that you have it. Okay, somehow I know that. Please give that web page number 1. I am providing the URL for that. Please give me. Then server will respond. And your TCP is going to carry that. Okay. Now finally through TCP they communicate. this TCP, whenever that response comes, that response will go through TCP. TCP will call Mr. Client. Client, you got a message from that server. Okay, please take and read it. I don't know what it is. So this is the way communication takes place. Okay. Now, once response is given, immediately this connection will be closed. Your server is going to terminate the connection. Such model is called non-persistent HTTP. That means user send a request, server will respond, that's it. Then after that there is no connection. Immediately your server will close the connection. Okay, I am talking about application level. I don't know about TCP connections. I don't want to talk about TCP connection. Okay, and of course if server doesn't want any connection, TCP connection also will be closed. That's a separate matter. I would like to talk about now application layer. So for every information, if you create a new communication line or you create a new communication path, that is called non-persistent connection. Okay, now one connection for one request, but generally it is not effective, isn't it? Why? Whenever you want a connection, we have to depend on TCP. We know connection establishment, termination, right? There is a lot of time, correct? There is a overhead. So that's why you tell me, whoever is watching my video, tell me which one is good, persistent or non-persistent. Though persistent is easy to implement, but we prefer persistent model. Where in persistent model, so connection will not be terminated. We wait for some time, so that if multiple requests comes from same client server. So once client send a request, server will respond. Then again client sends another request, server will respond. This entire thing will take place in only one connection. Okay, so in one connection, if multiple requests can happen, that is called persistent model. Usually persistent models are effective and efficient, isn't it? That's quite easy, because for every request we are not creating a new TCP connection, isn't it? Otherwise in non-persistent, for every request we have to create a TCP connection. That's why generally we go with persistent most of the times. Now we will see stateless protocols. HTTP is stateless protocol. Why, sir? I will tell you. Your server's behavior, if you observe, you understand that. So whenever client requests for a web page, server will respond, right? That is the way this HTTP protocol works. Now again client asks same web page. Example, let's say you ask a web page number 1, then he will respond with web page number 1, then ask web page number 1 again. He will give that web page one more time. But server won't say like this, my dear client, I don't give, because you just asked me, I gave you. Why are you asking one more time? What do you do with multiple pages? Of course they are same, right? Why are you asking me? So in that way, S will not disturb SC. Okay, S will forget about previous information. S says, though it is persistent or non-persistent, doesn't matter, everything same. Server thinks like this, that is not my business. Any number of time let him ask, I will give him. So in that way, so server won't remember the previous history, previous data. So that's why HTTP is called stateless protocol. Here server won't remember the previous information. That's it. That is about stateless protocol. Now we'll see the commands required in HTTP for this requirement. What is our requirement? Accessing the web pages. To access the web pages and some other stuff, what do you want? So one is get. First of all, I will read all these messages, message types, then remember them, because in GATE exam what kind of question they ask is, which of the following is an instruction in HTTP protocol. That's it, that kind of things. Okay, that's why just whoever watching my video, just remember that, just notify them, just notice them, that's it, that get is a HTTP protocols command. That is enough. Even if you don't know why we use get, why we use patch, why we use options, doesn't matter, especially for GATE, because it is all about memory, right? How much we can remember for GATE exam. There are 10 subjects and every subject has a lot of information. No one can remember. That's why try to remember, that's it. Okay, don't go into details. If you start understanding about patch, you can spend 10 days for that. Similarly, you want to go into details of GET, go to Wikipedia, then you get lot of information, but we generally forget, you don't require it, okay, because we have a limited time, so we have to understand only important things. So here what I want to tell you is, just remember these are all various instructions client is going to send. Already I told you one thing, there will be two types of messages, right? One is request message, second one response message, especially in HTTP protocol. So client is going to send a request message. What kind of request messages we can send is, you see, according to protocol, one message we can send is get message, head message, post message, put message, delete message, trace message, options and patch. These are all various types of messages we can request, okay. Now for every message server will respond appropriately, okay. So for server side there is no there is no this type of requests, correct. Only request will have names like this, okay, will have syntax. Response is different, okay. Example, what is difference between request and response, I will tell you. To understand that, first you understand get message, okay. When you send, that means whenever client send a get message, okay, this is client, this is server. Client sends, let's say, get message through proper syntax, forget about syntax. When this get message is sent, the meaning of that is how a server will understand it is, so somehow, because already I told you, protocol is going to define structure of the message and where is, this get is written, everything, semantics, everything. So server will understand that and he will understand like this. Get means client is asking complete web page. So that means get a web page, okay. Get web page number 1. In that way client is going to ask. Through get, client is going to ask web page. Get web page, okay. Now response is what? Response is okay, that's it. Yes, I will do it. So that's why response message types are not so important. So through usually the response messages are like yes, no, something like okay, everything. So they are not important, okay. But client side messages are important because they will be wide variety. We ask get message, second one, whenever you want to access a web page. Sometimes you don't want to access complete web page, but you want to access, this is your web page, you want to access only metadata. That means, very important information. What is the structure of the data, everything. So you know what is metadata, right? So it is information about data, structure of the data, everything, okay, not exact data. So that is metadata. So sometimes if you want to ask metadata of this web page, then we can ask. So that is all about structure of the data, not information in the data, information of data, okay. Now, so when you want that, client is going to, send a request message head. Similarly post. Example, you have a web page, you know that, right? Nowadays in Facebook, otherwise in any, question and answer website, we want to post something, right? We want to add some information. For that, we have to send a request post, okay. Similarly, we want to add some images or anything in some web page. For that, we are going to send a request message put, right? Similarly, we want to delete some information like, okay, from the web page. Probably we can use delete command, okay. Now similarly trace, I don't want to discuss these remaining things, they are not so important. Similarly, we have trace, options, patch. If you are interested, you have time, please go through Wikipedia and you can learn all these commands, okay. I don't want to discuss about them. So important messages are get comma, head comma, post, I can say, okay. But remember them, that's it. HTTP messages, get, head, put, in that way, post, delete, trace. If you remember, that is more than sufficient, okay. So this is all about your HTTP. Let me summarize. In HTTP there will be a client, there will be a server. Client will request a message through messages and server is going to respond. What kind of messages we can send is this one. And your HTTP is a stateless protocol. And one more thing, we can have persistent connections. That means in one connection multiple requests we can send. Otherwise for every request one different connection we can create. Of course I say that is useless and inefficient. This is about HTTP protocol, okay. Now we'll see the second protocol, that is file transfer protocol. So in file transfer protocol we have two computers and A wants to store a file in B. Otherwise A wants to retrieve a file from B. In any of the case, there is a file transfer, correct? So to govern that file transfer or to control the file transfer, we have a protocol, that is file transfer protocol. So HTTP also can be used for file transfer, not a problem, but I can say FTP is a specialist in that. Especially it is designed for file transfer. HTTP is a generic one. Even you can access any web page, okay, not only file. So the major difference between FTP and HTTP, if you see, one thing is FTP is going to maintain two connections, and one more thing, the similarity between HTTP and FTTP, if you want to know, HTTP and FTP is both are going to use TCP as underlying transport layer protocol. That means both are connection oriented protocols, I can say, okay. Even FTP requires a connection, but two connections. So here, whenever A wants to access a file from B, let's say for time being, then A is going to create, otherwise A is going to ask TCP, my dear TCP, please on behalf of me create two connections, okay. One is for data, second one for control. So in this control information, what we are going to do is we are going to exchange usernames and passwords, authentication. Why, we'll see. Generally, whenever you are accessing a file from another computer, then definitely you should be known person to B, correct? That's why A has to first of all submit the username password to B, then only we can access file of B. That is the way this protocol is designed. So finally, let's say A wants to access a file of B, then they have to exchange some control information. So typically A is going to send first of all his username password, okay. Assume that let's say A wants to access a file of B, okay. For that, first username and password will be transferred to B. That will be exchanged through a connection called control connection. There is another connection, that is data connection. So after this control connection, I mean the work is done, like username password is exchanged, B also agree on that. Let's say B satisfies with that information, then B will say okay, that is the response it will give. Then immediately data will be transferred through this connection. So there will be two connections. Why two connections is for efficiency. Here we are going to use this connection, and that connection will talk about or deal with only this control information only, because the structure of control information is different from structure of data, right? So it will be always easy to divide that two things in, I mean that will be easy for us to see that two things in a different way. So we can focus on how to exchange username password. For that we can implement simple protocols, and for exchanging the data we can generally require complicated protocols. There we are going to focus. That's why, so one connection will be used for control, one connection will be used for data transfer. That is one thing you should remember. Second one, your FTP connection is stateful protocol. That means that B, example, let's say this B which is going to give permission, it is going to remember the client. Who is that client? Example, let's say A is Raju, B is Rani, okay. Now whenever Raju sends his username and password R plus P, then B is going to remember them. Then second time when really that same Raju wants to access another file, then it is not required to send username password again. In that way, so Rani is going to remember Raju's information, okay. So in HTTP, so did you remember, we don't remember the previous activities, what is happened, right? But here that activities will be remembered, like what happened. So for multiple data transfers we remember the control information, remember it, okay. That's why FTP is called stateful protocol. We remember previous activities. That is one thing. Second thing, if you see in FTP, we have a control connection, we have data connection, right? Let's say FTP, here A, here B. So this is data connection, this is control. Example, let's say A wants to access some data file number 1, okay. For that he will submit control information, then B says okay. After that he will access the data. Once file number 1 is transferred, then now there are two things. One is control connection will be retained, that means we don't close it because there might be another file to transfer. That's why we keep control connection as it is, but we close data connection and we create another data connection, or we open another data connection for next file. Okay, in that way for every different file we are going to open a new connection. Generally that is a typical scenario, but only one common control connection, because that user information is same, right? But we are changing the data, then we are changing the structure of the data. That's why we have to, for the next file we have to assume other things like example, let's say for second file, what kind of structure this file is having, where it is, everything. So this connection will be reopened with new parameters. Okay, what kind of facilities you want. That's why I say that, remember one thing, in FTP once data transfer is done, connection will be closed. That's why we say it is non-persistent. Okay, now we will be opening the new connection if you want to have another file transfer. This is about this multiple connection story. Now we'll see various commands in your FTP. So we use user, pass, list, retrieve, store. Easily, these are all self-explanative, I can say. Whenever a host send this user command followed by username, then the receiver will understand that he is sending, that means that sender is sending user information. What is the username? And if you want to send password, we know that initially A has to send username password, correct? That's why different message structure will be given. For that the next command is password. Okay, we write pass followed by password. When you do that, then your receiver will understand that this is a password. Okay, in that way, so using these commands, user can understand what is username, what is password. List, what is this list? I will tell you. So whenever list is sent from A to B, B will understand like this. So that means A is expecting the directory, that means what are the files available in a current directory. Example, let's say A and B wants to communicate through file transfer protocol. So let's say B is having some current directory. In current directory there are 3 files, file 1, file 2, file 3. This is the hierarchy. Now A wants to know that. Okay, A wants to know what are the files available in the current directory. For that he will send a command list. Then B has to respond with the directory information. Okay, now retrieve. So here this retrieve is used to retrieve the data. That means whenever someone says retrieve, then the other party should respond with the file which has to be retrieved. Okay, example, let's say retrieve file number 1. Whenever this is given initiated by A, then B has to send that file to A. Okay, so here retrieve file name. Second one, same person A wants to store file at B. For that he will send this command. Example, let's say A wants to send a file F4 to B, especially he wants to store in current directory. Then he will write like this, store file 4, and he will send it. Whenever he send that information, then automatically B understands that so A wants to store some data at current directory. In that way various commands can be used. Remember these commands now: user, pass, list, retrieve, store. These are the various commands we use in FTP protocol. Okay.